I'm Barbara Tharp from Baylor College of Medicine, Center for Educational Outreach in Houston, Texas, and this is Michael Vu. Today we're going to do the second activity from the My World series on water, Disappearing Act. The objectives for the activity are aligned with the national science standards, both for physical science and science of inquiry. This activity uses guided inquiry to look at the physical properties of one of the most unique physical properties of water, its ability to dissolve different materials. Students will be able to observe water dissolving different materials, 6 different materials, and be able to observe, record, and draw conclusions regarding those materials. Michael, what are some of the concepts we're going to look at today?
So some of the concepts that students are going to explore involve solids and liquids dissolving in water, and if they dissolve, they're considered soluble. If those materials dissolve completely and disappear, or the water remains transparent, we consider this a solution. And also, there's 2 components to this. So we have a solute, which is the solid and liquid that goes into the water, which we consider the solvent.
Okay, very good. Thank you. Okay, how are we going to start today? Michael, what are we using?
Well, it's really important when you do the activity to engage your students. And what we want to do is take some prior knowledge or some experience that they have from their homes.
Okay.
And what we have here is a container of tea.
Okay, and we're going to look at this tea. We're going to, probably most students have had some experience with dissolving something. We're going to kind of jog their memory and ask them, to begin with, if you put sugar in tea, what happens? So the best way to do that, let them talk about it for a second, and then we're going to do it ourselves. So, okay, when we put the sugar in the water, as you can see, let's stir it a little bit, okay?
And you can see the granules of the sugar floating down to the bottom. Okay,
and then they disappear. Okay, and because the solid disappears into the liquid, we call that a solution. A solution. This is the solute, and this is the solvent. And that's what we're going to look at today. We're going to look at specifically 6 different household substances and how they dissolve, whether they do or don't dissolve in water. But to begin with, what we want to do is we want to have them predict what will dissolve and what won't dissolve.
What we want to do is listen to a workshop that we did with a group of teachers, elementary teachers, introducing this activity, and Barbara's going to talk about how to start this investigation with students.
Okay. What does dissolve mean? What does dissolve mean to anybody?
To break down.
To break down. Break down in what way?
Big particles to small particles.
Big particles go into small particles. Anybody agree with that? So if I was to say I'm going to take my cup, and it's going to have water in it, okay? And I'm going to put, along with the water, I'm going to put some sugar in there, okay? So I have water and sugar. And I take the sugar and I put it in the water and I stir. What's going to happen? It's going to dissolve. And most kids have seen that, right? So, but what happens if you, how many of you have had tea and you put sugar in your tea? And you keep putting sugar in your tea and you keep putting sugar. And after a while, what happens? It doesn't dissolve anymore, does it? It quits dissolving. So we have a point at which things don't dissolve anymore, and we call that what? Saturated. It's a saturated solution. These are things that kids see all the time, but they don't really understand so much why it happens. So we're going to look at not only what happens when you put sugar in water, but what happens when you put various other substances in water. Okay, so now that you've gotten an idea on how to start with your students, let's look at what the materials actually are that we're going to use. Michael, do you have the materials? We'll move this out of the way.
I have a tray set up in advance. And again, we suggest that students work in cooperative groups of 4 or 3, and each group would receive this set of materials. So what we have are 6 9-ounce cups. We have a measuring beaker. This is a 250 milliliter beaker. We have 6 stirring spoons, or you could use coffee stirrers. We also have 6 condiment cups. Each cup is filled with 6 different materials. We have 2 liquids. The first one is oil. The second one is a food coloring solution that we made ahead of time. We also have flour. We have ground coffee, salt, and sugar. And this is the materials that they will be testing.
Right. And you might notice that all these materials are very cheap or inexpensive materials. And where we do use a real science beaker, certainly teachers can use a cup. So there's nothing here that you can't get at the grocery store or wherever, or even at Burger King. Okay. Michael,
Well, now that we have the materials, we want to also talk about safety, and safety is always an important part of any investigation. Since we're dealing with solids and liquids, it's always important to emphasize to students that they are not allowed to eat or taste or smell any of the materials. Just the best rule of thumb is to follow your district's guideline. We are also dealing with food coloring, so we want to make sure that students are aware that it could stain their clothing, it could stain equipment, or their skin.
Okay, well, we've got the materials done, so now we're ready to start the activity. The first thing we always want to do is make sure that the students predict what's going to happen. But before we start that, we want the kids to think about it, okay? So I'm going to tell you what is the procedure we're going to use first. The procedure is we're going to have a tray. The tray's got 6 cups, okay? We're going to put the same amount, about 50 milliliters, so we're going to do some measuring. How many of your kids are really good at measuring and they do everything just perfect on measuring? Do you know what the problem is? They get to measure a couple times a year and they're finished, right? So we want to make sure that during science, that they measure and measure and measure. So we're going to give you a beaker, and you're going to put water. Well, you've got a beaker. You've got a beaker right here. And you're going to fill this beaker with water. And one of you will be the materials manager that gets the water. And then you're going to literally fill each one of these with the same amount. Let's suggest about 50 milliliters of water. So we have a 50 milliliter right here. Okay? So we're going to fill each one of these cups with about 50 milliliters of water to begin with. Then we're going to look at our substances, and we do have 6. And I'm not going to say what they are right now. What I want you to do is I'm going to give you the 6 substances on the tray, or you've got them on the tray, and what you're going to do is I want you to examine each one of them and look at it. Just really look at it, see what it is. And then you have a sheet where you're going to predict, is it going to dissolve? Is it going to mix up completely? Or is it going to end up, some of it not mixing in? Is it going to look clear? Is it going to look transparent? Is it going to look cloudy? What's it going to look like? What do you predict is going to happen when you put this substance inside the 50 milliliters of water? Now, there's one thing you have to consider as well, besides what the substance is, and that is how much are you going to put in, right? Like, we could pour all of it in, but are all these amounts equal? So would it be a fair test? So we want to make sure kids understand a fair test means that we use the same amount of water and the same amount of the substance, right? So you can either agree on an amount. We normally, depending on the grade level, with younger kids, I usually say just put, you got a teaspoon here, put a teaspoon of each one into each one of the cups. Now, the next thing is how are you going to treat it? Are you going to treat it by just watching it? And if you watch one of them, do you have to watch all of them? Or are you going to stir them? And if you stir one of them, are you going to stir all of them? You'd have to, right? The next thing is so what's stir mean? And these are things like, well, what does dissolve mean? What does stir mean? Well, if one kid says he's going to stir it like this, and the other kid's doing this, then it's not the same, is it? So you've got to agree. Like some kids come up with, well, I'm going to stir it 50 times, okay? 50 times. Or they may do back and forth 7 times, whatever. But it's got to be the same treatment. And this is something that's really neat because it explains to kids more about how scientists go about their work. If they're going to compare how something works, they have to have the same situation each time. They can't have variables all over the place, right? Because something consistent. So we're going to look at the same amount of water, the same amount of substance, and the same kind of treatment for each one. Okay, it looks like we have all the directions down now, and we're ready to begin the experiment. Okay, as we begin the experiment, you can see that Paul is measuring the amount of the first substance, which is flour, to put into the cup. Once he puts it in the cup, they've already agreed on a procedure. The procedure is to stir relatively vigorously around and around, and I think they've come up with an agreement of about 50 stirs. So as you watch him stir, you can see that the flour, although it is mixing in, it does not look like a solution because it's not clear, it's not transparent. What do you think, Michael?
Yeah, you can't see through it. Now we're looking at 2 different teachers. They're going to have their own set of procedures. They're going to be testing oil in this particular trial. And as you can see, they're going to measure out again equal amounts. They're going to take 1 teaspoon of oil and place it into the water. And their stirring technique is a little bit different. As you can see from this video, the water and the oil do not mix. The oil stays on top. Even though they're transparent, they're not evenly distributed.
Okay, as you can see from the student recording sheet, at each time they have a prediction and then they have the actual results recorded. It looks like this group is going to begin testing another one of their substances It looks like food coloring, diluted food coloring. Again, they're going to measure a specific amount, pour it in, and mix it with water, the solvent. You can see immediately that we have a solution because it's transparent. Look at their stirring method. Their stirring method is very different, back and forth in just a few times.
Looks like they're recording their observations after they've made their predictions.
Excellent. Okay, now I think they're going to test another substance. It looks like this time they're going to be testing coffee. This is not coffee grounds. It is ground coffee. But they did not know this in the beginning. It looked more like instant coffee, so many of them predicted that it would dissolve. Instead, what you're seeing is some dissolving. There's a little bit of change in the color, but there's much of the coffee bean, the ground bean, is still floating on top. This was a surprise for many of them.
And we also want to mention that they tested salt and sugar earlier, and as we know that salt and sugar dissolve very easily in water.
As you can see from the experiment, all the teachers had different methods. Some of them stirred more, some of them stirred less, some of them measured more, some of them measured less. It's really important that students have the opportunity to think about the experiment their own way and come up with their own their own procedure.
Something to consider is that if students use a larger amount of solutes to the solvent, you're going to have an oversaturated solution. So they could put in a large amount of salt and sugar and not get it all to dissolve. So keep that in mind and make sure that students understand it as they conduct their investigations.
Okay, and now let's look at the food coloring. You can see that once the food coloring was added, that it's completely transparent. Michael?
And also that it's evenly distributed, which is really important to be a solution.
For them students to understand that you can't see one or the other that's mixed together completely. When you look at the oil, you see a completely different thing happening. The oil does not mix. It's not a solution. The oil stays on top of the water. The oil is less dense than the water. So, Michael, is this a solution?
No, I mean, again, even though it's transparent, you still see two different components.
Two different components. And with the coffee, like I said earlier, they thought that it possibly was instant coffee or coffee grounds from coffee that was already made. But instead, we gave them ground coffee beans just to be kind of a little bit, give them something to think about there. And what happened is you can see when you stir it, you do have some dissolving, so you have some solution. You have the color, but it's not a complete solution. Okay, Michael, what about the flour?
Again, we stirred up this flour, and you can see that the particles, even though they're very tiny compared to the coffee, are completely uniformly distributed in the water, but it's not transparent. You can still see the particles, and since there's so many of them, it becomes an opaque mixture.
So we don't call that a solution?
No.
Okay, so what are the water basics behind the disappearing act? To begin with, water is called a universal solvent. That means that it dissolves, although it doesn't dissolve all materials, it dissolves almost all materials. This is a very unique property of water. Another property, Michael?
So another property would be when a material is dissolved completely in water, we consider it a solution.
Okay, why does this happen? I think it has to do with the molecular structure. This is something that we don't often talk about in elementary school, but just a basic understanding really will, I think, help make us understand why this works the way it does. Water molecules are polar molecules. That means that they have a positive end and a negative end. And this positive and negative end are responsible for dissolving other materials that also have a positive and negative end. And Michael, what does that have to do with materials that won't dissolve in water?
Well, Barbara, it all has to do with the molecule again. So materials, solids and liquids that don't dissolve in water typically have a very different molecular structure. They tend not to have, or they don't have, positive and negative ends like polar molecules. And so they don't dissolve in water for that reason.
Or break apart.
Right.
Okay, so these are some of the most important properties of water. And with this activity, we're looking at solubility. Okay, with all these materials, it's the teachable moment when students want to know, well, what would happen if? And so we look at extensions. What would happen if, for instance, we mixed all the materials together? What would happen if we tried to filter some of the materials out? So I think it's really important for the students to be able to look at those questions and come up with answers. Another thing they can do is, what will happen if we let the water evaporate over time? So it's a good idea to let the things sit out and find out what happens if they evaporate over time. What happens if you keep stirring them? What happens if you add more to it? There's a lot of questions that students have that can be extensions to this activity, as well as, Michael?
Well, Barbara, we can also look at saturated solutions. We've been talking about it, and again, it's another learning opportunity. So what we have here is a beaker that we filled up with water. We mixed in borax solution, which is a detergent, and we allowed the water to evaporate out. We even left a spoon in it. As you can see, students can observe these very cool deposits of the detergent on the spoon as the water evaporated. You can do this with sugar, you can do this with salt, you can do it with a lot of things that you can dissolve into water and kind of reverse the experiment and see what happens. Another thing that you can do is to have students create another experiment that deals with controls or variables. And what we have here are 3 cups that we set up. We have students, we provide students with different temperature, water of different temperature, and we have them fill the container up. Make sure that they measure what the temperature is and then mark it on the cup. And then we see how long it takes for the material that they use to dissolve in these different water temperatures. So this is another extension of this activity.
And the most important part of this activity is to make sure that the students have fun. That means experimenting. Michael, what's going to happen now?
It's going to get messy. My mom would never let me do this at home.
Remember, science should be fun and a learning experience.